Okay, welcome each and every one of you. The recording has begun. This is day 2, week number 7 of our journey together, and it's a delight to have each and every one of you here at this time. All right, so what I want you to do is I'm going to be writing on the screen, and I want you to um, write down what I have. Someone saying something? Okay, all right, no problem. No problem, Miss Johnson. I want you to write down the things that I'm going to write today. So write them down. So make sure you have something to write on and something to write with. All right. So make sure you have something to write on and something to write with. And once you do, you can take down the notes that I will give you. And then after that, you can send me the class notes to my WhatsApp number. All right. Okay. Anyone can remember the topic that we was on yesterday? Just looking at what? Okay. So today is Tuesday. Tuesday. Sierra, you remember what we was looking at yesterday?
Yes, so we're looking at probability.
Mm-hmm. Probability.
Uh,
That's what rule? What new rule we learned yesterday?
we learned the multiplication rule of probability.
Yeah, the multiplication rule of probability. August 2022. So subject is mathematics, and the topic, of course, is combined probabilities. Combined probabilities. When we say combined probabilities, of course, we're talking about the addition rule and the multiplication rule. All right. So we're gonna begin with an exercise that captures some of what we learned yesterday, and we're gonna continue with that with those ideas. We might get into the trees today, depending on how much we cover. All right, so let's begin. Let's begin with exercise number 1. So this question says that let's say you have 8 counters. So so 8 counters, and we said what is a counter? A counter. Remember we looked at this before, but a counter is basically the things that you use to count with when you're very small. So counters are stuff like this. These little circles, these are counters. And imagine that these counters, imagine that these counters have numbers on them. Okay, so let's go back there. So 8 counters, numbered 1, 2, 3, 4, 5, 6, 7, 8, are placed in a box. Okay, so you have 8 counters. They are placed in a box. And these counters, they are numbered from 1 to 8. And we have them inside a box. 1 is taken. 1 is taken out at random. And what? And replaced. A second one is taken out. What is the probability that A both are number 5, B both are even numbers, both are prime numbers, both are divisible by 3, and both are divisible by 3 if the first is not replaced. Okay, so those are our 5 questions. Very similar to what we did yesterday, but hopefully today we can approach it with a better understanding. All right. Okay, so what is the probability that both are number 5? So let's begin with A. So first of all, let's understand what's happening. And to do that, I'm gonna basically give you an illustration. So what's happening is, here's the idea. So we have, what is this? This is like a box, right? So you have a box, and in this box, you have these counters. So these counters, so that's, you have how much counters you have? We actually have 8 counters. 1, 2, 3, 4, 5, 6, 7, and 8. Now each of these counters are numbered. Alright, so 1, 2, 3, 4, 5, 6, 7, and 8. So each of them are numbered, right? So 1, 2, 3, 4, 5, 6, 7, and 8. Each of the counters are numbered. So the idea is that we are taking out one counter out of the box. So let's say, for example, we took out the number 1, took out that one out the box. So that moved that, we moved that, so we took it out the box. And remember, when we take it out the box, the next step we do is we put it back. Okay, so after we take it out of the box, we put it back. Okay, and then we take another one out of the box. So we could take say 5. All right, and so now 5 is gone. So that's the experiment. We are taking out a counter out of the box, putting it back in, right, and then taking another one out, or maybe even the same one out. That is the experiment. Okay. So now, excuse me, what is the probability of us getting both numbers are 5? Both numbers landing. Sorry, both numbers when you take it out the bag, right? Both numbers land. Both when you take it out the box rather, you get 5 on both occasions. So let's say for example you took out 5 the first time, and then you put 5 back again, and then you end up taking out 5 again. So that means that both are 5. So the counter that you took was 5 twice, right? So that's what they're trying to say. There's a probability of that happening. So Deja, if I want to figure out the probability that both are 5, what must I do?
Well, you have to multiply the probability of A by the probability of B. So if you get both are 5, then you'd have to multiply what you get for 5. I think
Okay.
it's 1/8
So
times 1/8.
okay. So the probability that the first one is 5, right? Um, multiplied by, so first counter, let's say first is 5 because I don't want to make it too long. So the first is 5 multiplied by, so that means that the first counter that you pulled was 5, and multiplied it by the probability um, that the second is 5. The second one you pull out is 5. So the probability that both are 5 is going to be equal to, what is the probability that the first one is 5? Deja, would you say it again?
I said I think it's 1/8.
1 over 8. So it's 1 over 8 because, well, it's only one counter that has 5 out of 8. And we're going to multiply that by, well, once you put that back, yeah, once you put it back, you still have 8. You still have 8 counters to choose from. So it's going to be 1 over 8 multiplied by 1 over 8. Okay, so it's going to be equal to 1 times 1.
Hello.
Hey, Albanique.
I just wanted to say, I don't know if any guarantee to stay on, but I am in the class now.
Yeah, I noticed, right? Yeah, I hope the internet holds up for you. So, good. What is 1 times 1? That's going to give us 1. And what is 8 times 8? That's what?
64.
64. Okay. So the probability that we get both are 5 is going to be 1 over 64. Okay. Okay. Now we want the probability that both are even. Okay, so if we want the probability that both are even, Caitlin, what must we do?
Versus 2.
Say it again.
4/8.
I could barely hear you. Say it again.
4/8.
4 over 8 multiplied by what?
4/8.
Okay, good. So if we're trying to figure out the probability that both are even, it must be the probability that the first one is even multiplied by the probability that the second one is even. Okay, so the probability that both are even is going to be equal to um um Ciara Linton, are you there? Hello, Ciara Linton, are you there? How about Jonathan Linton, are you there? All right, my mic is not working.
Yes, I'm here.
Okay, hello, Mr. Jonathan. Okay, are you now to Ciara so you can let her speak through your mic because she said her mic is not
Yes, sir.
working? Okay,
Yes,
yes,
sir.
let her use your mic, please.
See, Rachel.
Okay, good. Hello, Ciara.
Yes, sir.
Okay, great. Um, how much even numbers we have inside this box?
4,
Four, okay. What are they?
2,
Mm-hmm.
4, 6, 8.
Very good. Excellent. All right, so just like how Caitlin told us earlier, the first one is going to be 4 out of 8. So since it's 4 even numbers, okay, out of 8, then it's going to be 4 over 8. So Ciara and Jonathan, I know that y'all are here for the first time. Make sure write down or take down the notes that are given in this class, and then once you are done, once class is over, send me the class notes via WhatsApp. So let me put my
Yes.
WhatsApp number on the in the chat box. It's 426-8891. So once you have finished taking down the class notes, once class over, send me the class notes on WhatsApp, okay?
Yes, sir.
Okay, great. It's gonna be equal to 4 over 8 multiplied by 4 over 8. Okay. And Sienna, what is 4 times 4?
16.
16. And what is 8 times 8?
64.
Very good, 64. Now if we were to simplify it, Deja, what would we use?
16.
16. Okay. 16 goes into itself how much times?
Once.
Once. And 16 divided by, and 64 divided by 16 is what?
4.
It's 4. So here we used 16. So we divide the top by 16. So divide by 16. Excuse me, that gives us 1. and the bottom we divide by 16 to give us 4. So the probability that both are even is 1 over 4. The probability that both are 5 is 1 over 64. All right, Jasmine, are you here? Jasmine Low, are you here?
Yes, sir.
Okay, good. All right, so what are the prime numbers that are inside this box? Remember, the box only contains numbers from 1 to 8. So what are the prime numbers that are inside this box?
Is 1 to 8.
Yeah, the box contains numbers from 1 to 8. So what are...
2,
Mm-hmm.
3,
Yes.
5,
Mm-hmm.
and 7.
Very good. So, excellent, Miss Jasmine. So if you look carefully, right? All right, if you look carefully inside the box, we have 1, 2, 3, 4, 5, 6, 7, and 8. So the only prime numbers that we have, remember 1 is not prime, it's going to be 2, 3 is prime, 5 is prime, and 7 is prime. So there are 4 prime numbers altogether inside this box. So that means that when we considering the probability that both are prime, we want to separate it by saying that we want the probability that the first is prime multiplied by the probability that the second is prime. And so, like Jasmine said, there are 4 prime numbers inside this box. So that means that in this case, the probability of getting a prime number is going to be 4 over 8 because there are 4 prime numbers and 8 numbers in total in the box. And we're going to multiply them by 4 over 8 because it's still 8 numbers inside the box because remember you replace what you took back into the box. All right, so Mr. Jonathan, what is 4 times 4?
16.
16, very good. So 4 times 4 is 16. And Ciara Linton, what is 8 times 8?
64.
64, very good. And if we simplify it, Miss Sans, what do we get?
1 over 4.
1 over 4. Very good, because we divide top and bottom by 16. All right. So Deja, light work, right?
Pardon?
Light work, right?
I guess so.
I guess so. Okay. So far, you'd say.
So far.
Okay. All right. So let's see about D and E. All right. Let's see if we can manage ourselves with those ones. So let's see, it's going to be the probability that both are divisible by 3, which means that 3 can go into it without leaving a remainder. Okay, so Caitlin, inside the box, which numbers are divisible by 3?
3 and 6.
3 and 6. Excellent, very good. 3 and 6, because 3 divided by 3 is what, Sienna?
Sienna went somewhere.
Okay, 3 divided by 3, Caitlin, is what? Go ahead, Kate. Go ahead, Caitlin. 3 divided by 3 is what? Pardon?
Yeah.
Say it again. I missed that. What is 3 divided by 3? Go ahead, Caitlin. What is 3 divided by 3?
1.
1. Very good. And what is 6 divided by 3?
2.
Very good. So the only two numbers here that are divisible by 3. Only two numbers inside this box that is divisible by 3. And that is, like, see, Caitlin said, only 3, only 3 and 6 was divisible by 3. So what's going to be our probability, Sierra, of the first divisible by 3?
2 over 8.
2 over 8. Very good. Why 2 over 8?
Because there's only 2 numbers that are divisible by 3.
Very good. Out of the entire 8 that we have. And this one we're going to multiply that by what, Sierra?
2 over 8.
2 over 8. Very good. It's going to be 2 over 8. So it's 2 over 8 multiplied by 2 over 8. And Mr. Jonathan, what is 2 times 2?
4.
Very good. And what is 8 times 8? Jonathan?
64.
Very good. 64. Alright. So 4 over 64. And how do we simplify this, Deidre?
Divided by 4.
Okay.
So you get 1 over 16.
Yeah, 1 over 16. Because 4 goes in itself once, and 4 goes into 6, and 4 goes into 64 16 times. So 1 over 16. Okay. Alright. Now, F is where everybody is, you know, oh my, I forget F and G. I didn't give you all F and G. Anyway, we could do it. Well, how did I leave off? I leave off. Okay, I didn't do F and G, so So both are divisible by 3 if the first is not replaced. So we want the probability that both are divisible by 3. But remember, there is no replacement for this one. So I'm gonna put it in, I guess maybe I can make a note of that. Capital N R. So no replacement. Okay, that's what we mean by capital N R, no replacement. So both are divisible by 3, but this time we are not going to replace the first one we take. So it's going to be the probability that the first one is divisible by 3 multiplied the probability that the second one is divisible by 3. Okay, but remember, no replacement for these ones. We don't have to put that down. We already noticed that. Okay, now Deja, help me out with this probability. What's going to be the probability of the first is divisible by 3?
Will the first one be 2/8 and the second one be 1/7?
Yes, very good. So 2/8. See, I told you math is easy, don't make it hard.
That's debatable.
That's debatable, eh? Alright, 2/8 because there are two numbers there that are divisible by 3 and 6. Okay, so let's say we take out 3. So let's say we took out 3. Remember, in this case, we do not replace the 3 back. So we take it out. We don't replace it back. So no more 3. So we are left with 7 numbers left because 1, 2, 3, 1, 2, 4, 5, 6, 7, 8. So altogether 7 numbers that are left. So that's why you have the 7 at the bottom. And there's only one number that's divisible by 3 now, which is 6. So that's why this one is 2/8 times 1/7. So be careful. It's 2/8 because initially we had two numbers that are divisible by 3 over 8. But now since we remove that number, one of those numbers that's divisible by 3, you only have 1 left out of 7. So it's going to be 1/7. Now, Ciara Linton, what is 2 times 1?
2.
2, very good. Let me clear our drawing. So here we have 2 times 1, which is 2. And what is 8 times 7, Ciara Linton?
56.
Yes, ma'am, 56. Can you pronounce your name for me, Miss Linton? So I would make sure I pronounce it right.
Kiara.
Oh, Kiara. Okay.
Yes, yes.
And Miss Sans, your name is Ciara, right?
Yes, sir.
So Ciara. Okay. I can try to remember that. If I can't remember, I'll just pronounce the last name. So it's 2/56. So how can we simplify it, Caitlin? 2/56. What did we use? Hello, Caitlin, are you there? I'm not hearing from Caitlin. Sienna, are you there?
Yes, sir.
Okay. We have 2 over 56. How can we simplify that?
2.
Okay, you want to use 2? Okay, 2 divided by 2 is what?
1.
Okay, good. And divide 56 by 2, and you get what?
28.
So 1 over... Where's your sister? I don't hear her from her.
I don't know. I have to check.
Okay. So 1 over 28. Okay. Good. Good. Alright, so that's that. Alright, there are other questions like F and G, but I am not going to ask that. I think we're good on those. Alright, so any questions on this? Alright, so I guess not. So let's do an exercise. So it's going to be exercise number 2. So this one I want you to try on your own. So let's say we have 2 dice are thrown. What is the probability that A, 1 is 3 and 1 is 4? It's probability that only 1 is 6. It's the probability that both are even numbers. It's the probability that the total score is 12. Probability that neither is a 1. Okay. Alright, so I'm going to give you 3 minutes to try this on your own. And once we come back, we can answer it together. So the timer has begun. You have 3 minutes to attack this question. 2 dice are thrown. The probability that 1 is 3, 1 is 4, only a 1 is 6, both are even. The score is 12 and neither is a 1. So write this down and attempt it on your own. Okay, so the timer is almost done. All right, that's time. Okay, let's begin with the first one. Anyone want to volunteer to do the first one? Any volunteers for the first one? Oh, okay, let me volunteer someone. Okay, let's go Sienna. Probability is 1 is 3 and 1 is 4. My bad, sorry, I meant to call Sierra, sorry. Sierra, what's the probability that 1 is 3 and 1 is 4?
1 over 6.
1 over 6. Remember, 2 dice is thrown. So you want the probability that 1 is 3 and 1 is 4. So be careful. Anyone else? So we assuming that we can assume that that the dice are indistinguishable. Sorry, that the dice are distinguishable, which means that you can tell them apart from each other. So, well, there's actually 2 ways this could happen. So, so what happens if the answer is 2? Okay, so what happens if say we have that okay, so it could happen like, okay, so if 1 is 3 and 1 is 4, it could happen whereby the first dice, so you have this dice, so let's see, you have the red dice, right? And then let's say you have the blue dice. Okay, so you have the blue dice and you have the red dice. So it could happen whereby the red one land on 3, but the blue one land on 4. That's a possibility. If that happens, the possibility of the red one landing on 3 is actually going to be 1 out of 6, and the probability that the blue one land on 4 is actually going to be 1 out of 6. Okay, so that's one way that can happen. Another way that this can happen is that another thing that can happen is that instead of the red one landing on 3 and the blue one landing on 3, it could be different. So what can happen is that the blue one could land on 3. Sorry, the red one could land on 3, and the blue one could land on 4. Is that how I had it the first time? Why switch it? Yeah. So is this how I had it the first time? I can't remember. Or I switch it. Anyone can remember?
Wrongly.
Say it again.
You put the same thing back.
I put the same thing back. Okay, wrong way. Okay, thank you. So what could happen is the 4 could land on, the red one could land on 4, and the blue could land on 3. Okay, so in that case, if the red one lands on 4, well, it's only 1 out of 6, and if the blue one lands on 3, it's only 1 out of 6. Okay, so altogether, the probability of me getting 1 is 3 and 1 is 4 is going to be 1 times 1, which is 1. And what is 6 times 6?
36.
36. Very good. All right. Plus 1 times 1, which is 1, all over 6 times 6, which is 36. Okay, so what's the answer for this one? What's the answer? Well, you add the top, so 1 plus 1 is 2,
2.
and you keep the bottom, so you don't add the bottom because they're the same denominator. Yeah,
Okay.
so yeah, 36.
Only when you're multiplying, right?
Yeah, only when you multiply. Okay, so 2 over 36, we could simplify that. But Deja, how could we simplify it?
Divide by 2. But I asked him, how come you gone this way though? Just like I was thinking about what you to give us some long time with all of that, and I was saying I had equals to 36. That's the one I was using. What does this mean?
You'd still get the same answer, you know. You know that, right?
I know, but I trying to figure out. I do want the same answer, but I trying to figure out how you get this. Like, how does this make? Like,
Oh,
I
the
don't even understand.
reason why I did it like this is because I'm trying to use the rules. Okay. We could have done it that way and still get 2 over 36, but that would have been a shortcut way. I wanna use the rules to get the answers, so that's why I did it this way. Okay. So here we use the multiplication rule. All right, and then we use the multiplication rule again, and then here we use the addition rule. So it's a combination of the multiplication rule and the addition rule combined. That's how we got it.
That's what I don't get. Maybe I'm missing something. It's the same thing I was confused about yesterday.
Okay.
Okay, so the red could either be 3 and the blue could be 4, or the blue could be 3 and the red could be 4.
Yes. So okay,
Yeah.
here's the thing, right? So you have to use so for this one we had the red is 3 and the blue is 4. Remember? And then for this one we had the red is 4 and the blue is 3. Okay, so the red being 3 and the blue being 4, can that happen at the same time?
No.
Why not? If I roll a dice, I have 2 dice in my hand, I roll them, the red one land on 3, the blue one land on 4. Can that happen at the same time?
If you say 2 dice or 1 dice.
I have 2 dice. I throw them, the red one land on 3, the blue one land on 4. Can that happen?
Yes, so.
Okay, Deja, can that happen?
You said a red one line on 4 and the blue one line on 4?
No, look at the coloring I have. The red one land on 3, the blue one land on 4.
But yeah, that could happen at the same time.
Good. So they're independent events, right? One doesn't affect the other. They could happen at the same time. So remember, the multiplication rule happens for independent events, events that don't affect each other, which could happen simultaneously, all right? Or what could happen and the probability of one doesn't affect the probability of the other, okay? So 3 and 4, we could have a red landing on 3 and the blue landing on 4. That's one way that we could get 1 is 3 and 1 is 4. Now, the other way that we could get 1 is 3 and 1 is 4 is that the red one could land on 4 and the blue one could land on 3, right? That's another entirely other option, right? Now, these two, Deja, this one and this one, can they happen at the same time? Can they occur at the same time?
No, sir.
No. So what do we call events that can occur at the same time?
Mutually exclusive.
Good. So for mutually exclusive events, what rule we gotta use?
Addition.
Good. So that's why we add them. Okay.
Like, this will be hard to remember though. Like, when do we know if we have an exam we're gonna have to use this?
You gotta follow. You gotta look at the events, right? Are they independent? Are they mutually exclusive? And it's easy to remember because think of it. This could happen one way, or it could happen in another way. So you know you're gonna add them. Like, it ain't rocket science. And how you can get the first option? Well, in order to get the first option, you want red and blue. Red and blue. Well, that's using and. So that's intersection. That's multiplication rule. You want blue and red. That's, you want 3 and 4 and 4 and 3. That's, they're telling you out loud multiplication rule. Okay. So I guess maybe as you practice more, you'll get familiar with your own feel of how to get it, but it stands out at you readily once you get the hang of it. All right. Okay. I want to know, can y'all see this participants box? Like when I move it around, or it doesn't appear on your screen?
You said we see a box?
Yeah, a box would say participants and have the names of the participants inside the box. Y'all could see that?
I can't.
Oh, so it's not visible.
I can't either.
Oh, I thought it was visible to y'all. Okay, so y'all can't see it. Alright, that's neat. Oh. Okay, there's actually a box here that's like hiding. Like I actually have it over the words. Okay, interesting. Y'all can't see it. That's good. Well, that's good. Because the reason why I didn't have it up is because I'm like, I don't want to cover the words. But it doesn't show. Okay, that's interesting. How about now? Does it show?
I have a question.
One moment. How about now? Do you see the box? Participants? See it? Hello, let me know. Do you see the box?
No, sir. Oh, I saw a box flash just now, but I don't see it no more.
Okay. Alright. Go ahead, Albanique.
So I was just wondering if it's possible, like, can you like do like the 1/36 plus 1/36, and then you do times one?
Say it again. Can you do? Ask the question again, please.
Never mind.
Okay, no problem. Alright, so now we want the probability that only 1 is 6. Alright, so the probability that only 1 is 6. So, alright, so only 1 is 6. So that could happen in two ways, right? So the probability that only 1 is 6 could happen whereby the first is 6, the first number that you, the first, I hate to say first because we don't really have order here, but let's pretend that we dealing with a red and blue dice, right? So which ways this could happen? Well, it could happen in two ways. The first way is that you could either have it where the red one land on 6, or you could have it and the blue one doesn't land on 6, and you could have it where the blue one lands on 6 and the red one doesn't land on 6, right? So the way that we could do that is we have to break it down into 2. So this is interesting. You got to pay close attention because remember, for this time the red one is landing on 6. The blue one can't land on 6. It can land on anything, but it can't land on 6. All right, because it's a only one is 6, so only one is going to land on 6. One of these dice is going to land on 6, and this time it's going to be the red one that land on 6. Let's say. Okay, so that means that there's only one way that this guy. What's the probability of, well, the first one have the land on 6. But don't have no other choice. You really don't have no other choice. I'm thinking about it. So if we look at it, all right, let's think about it. So if we go back to our outcomes, right? We know that what could happen. We could have 1 6. We could have not 1 6. We could have sorry. We could have. So if the red one land on 6, let's say the red one is the one that lands on 6. That's the first one. So it's gonna be 6 1, 6 2. Remember the second one can land on any other number. 6 3.
I count 11. I ain't sure I was right.
You count 11. Okay.
That's
6.
what I count, but I ain't sure I was right.
All right.
Because
No
I
problem.
see you starting with 6.
Okay. 6 5. And we can't count 6 6 because both of them can't be 6 at the same time. All right. So then there's that. So we would have had 6 6, but obviously we can't count that because we only want one of them to be 6. The next thing that could happen would be well, it could be if we have the blue one land on 6. That's the second one. So that means that we have the first one can't land on 6, so it's 1 6, 2 6, 3 6, 4 6, and 5 6. Okay, so altogether that's how much? 1 2
No, that's
3
10.
4 5 6 7 8 9 10. How you get 11?
I miss and count 6 6.
Oh, you count 6 6. Okay, yeah, both of them can't be 6 together. Okay, so 11 out of 36 is the answer. I'm sorry, 10 out of 36 is the answer. Alright, so it makes sense now. Okay, so so the thing here is that it's this, right? So we want the probability that the first one land on 6. So the first one land on 6 is going to be 1 out of 6. And the second one, it could be, there are 6 options, right? We want the probability that it lands on a number that's different than 6. So it's going to be 5 out of 6 because it can't land on 6. Okay? So plus, this time, the blue one land on 6. So the first one doesn't have the land on 6. So it's going to be, it has 5 options out of 6 multiplied by the second one have the land on 6. So it's only one option for 6 out of 6 options. And so that's going to be is you're going to have 1 times 5, which is 5 divided by 36 plus 5 times 1. What is 5 times 1? Kiara. 5 times 1 is what? Kiara Linton. 5 times 1 is what?
5.
5. Very good. Over what is 6 times 6?
36.
36. Very good. Now if we add them, Jasmine, what do we get when we add them? Jasmine, Low, what do we get when we add them? Okay. Sierra, what do we get when we add them?
Okay, we get 10 out of 36.
10 out of 36. Alright, so it's going to be equal to, let me
If
simplify.
you reduce it by 2,
Uh-huh.
you can get 5 over 18.
5 over 18. Alright, any questions on that?
So,
Uh-huh.
so just like how when we do the red and blue for A,
Mm-hmm.
and that means that this first bracket was an independent event.
Mm-hmm.
So it means that the red dice went on what? Hold on. Yeah, the red dice got on 6,
Mm-hmm.
and or what am I saying? The red dice didn't go on. The first one didn't go on 6, or the second one went on 6.
Okay, so remember the red one for this one went on 6 because it's only 1 over 6. There's the probability of it landing on 6 is 1 over 6 because there's only 1 6 there, right? Now for this one, this dice land on a number that wasn't 6. So the probability of that happening is 5 over 6 because there are 5 ways that could happen. They gotta land on 1, 2, 3, 4, or 5. You understand what I'm saying? For this one.
And so
Good. And then the second one is the opposite. You get that? So that's how we
I
get.
don't even know why I'm lost.
You don't know why you lost?
No, it says only 1 is 6, but I get it, but I still don't get it. But okay.
Oh my. Yeah. Okay. But at least you get it this way though. I hope. I hope you understand at
I
least.
did.
Okay, that's good. This one is a bit, this way is a bit interesting, but we have to go through it because it's a part of your syllabus and you can't duck it. So So let's move on. So the probability that both are even numbers. Okay. So the probability that both are even numbers. Well, that's enormous. That's a lot. So that means that both of them have to be even numbers. And okay, well, okay. So when we roll the red dice, we want that to be an even number. How much even numbers we have on a dice? So we have 1, 2, 3, 4, 5, and 6. So Caitlin, how much even numbers we have on a dice? Caitlin?
3 on each dice.
Very good. 3. So 2 is 1, 4 is another one, and 5 is another one. So if we want the first one to be an even number, well, that can happen this way. 3 over 36. Not 3 over 36, 3 over 6, because the red one, that first red one, is going to land on an even number. So that's 3 over 6 multiplied by the probability that the second one is an even number, is also going to be 3 over 6. All right. That'll give us 9 over 36. I just don't feel that that's right, because we want both the 30s. Both are even. Let's check. Okay, good. Both are even. So that'll be, we want the probability that both are even. So that'll be, this is 1. That's 2. This is 3. This is 4. This is 5. This is 6. Yeah, this is 7. This is 8. And this is 9. Yeah, that's correct. Yeah. It is 9 over 36 for real. Okay. Okay. So the probability that both are even, so let's do that on top. Let me do it where it belongs. So the probability that both are even, remember we want the first one to be an even number. It's going to be 3 over 36. Sorry, 3 over 6. Because there are 3 even numbers and it's 6 sides of a dice. Multiply that by, again, we have 3 even numbers for the blue dice. And divided by 6 sides of the dice that are there. So it's going to be 3 times 3, which is 9. All over 6 times 6, which is 36. All right. How can we simplify this? Deja?
Divide by 9.
Divide by 9. 9 divided by
1
9.
over 4.
1 over 4. Very good. Okay. Now we want the probability that the score is 12. That should be easy. The probability that the score is 12. All right. The probability that the score is 12. Anyone got that answer? So when we add up the, well, they say the score is 12.
Would that be 1 over 6 times 1 over 6? There's 1 6, and then if you have 2 6, then you get 12.
Yeah, so we mean, let's say the sum instead of saying the score, because it sounds. So the sum of the two dice is 6. Is 12. Let's see. There's only one way that can happen. One is 6, and the other one is 6. There's really only one way. We can't. Yeah, there's really only one way that can happen. So 1 over 36 is our answer. It's the same thing as saying 1 over 6 times 1 over 6, which gives us, if we were to do the working for this, we'd say, well, the first one must land on 6. So that happens as 1 over 6. The second must also land on 6. So that's 1 over 6. So that's going to give us 1 times 1 is 1. And 6 times 6 is 36. And finally, the last one, E, the probability that neither is a 1. So neither is 1. So that means that the first one can be 1. And the second one can be 1. Alright, so let's do this. So alright, this could happen in multiple ways, Carly. Alright, so this could happen in multiple ways. The first way it could happen is that what if the first one is not 1? Neither is 1. Okay, so none could be 1. Okay. So the first one can't be 1, neither the second one could be 1. Alright, that's pretty simple. So that means that the first one have to be a number that's not 1. And the second one have to be a number that's not 1. Okay. So if it's not 1, then that means there are 5 options you could choose from. So the first one gotta be 5 over 6.
2, 3, 4.
Say it again. Say it again, Deja.
Wait, never mind.
Okay. Yeah, like there are 1, 2, 3, 4, 5, 6 sides of a dice. So if the first one, if we can't choose 1, that means we are left with 5. So it's gonna be,
I think I know what I was saying. 2, 3, 4, 5, 6.
yeah, exactly.
Oh.
So 5 over 6 are gonna be your 5 numbers that you could choose from. And then you have to do it for the second dice as well, because it's 2 dice that you are throwing. So 5 over 6 times 5 over 6. So Jonathan Linton, what is 5 times 5? Jonathan,
25.
25, very good. And what is 6 times 6?
36.
36, very good. Alright, can we simplify these two? Any further? Sierra, can we simplify this any further?
I don't think so.
No, we can't. Very good. There's no number that is a common factor of these two besides 1. Okay,
Excuse me.
go ahead.
What if like we were to do it like
What if we like we
like
wanted,
comma 6, 3, comma 6, 4, comma 6, 5, comma 6, and then do it again around
what if we wanted to do what?
like 5 or 4.
I could barely hear you. What if we wanted to do what?
Like what if we like do 2, 6, 3, 6, 4, 6, 5, 6, and I'll be like 5/6.
Ask the question one more time. What if we wanted to do?
Maybe like do a line down and then you put like 2, 6, 3, 6, 4, 6, 5, 6, and I'll be like 5/6 times 5/6, and you just do the rest from there.
Okay, no, you don't want to do it that way. What you want to do is you want to remember that they say that you don't want none of them to be 1. So that means that the first one you choose, like for the red dice, the first one you choose, it cannot be a 1. So that means you can't choose 1. So that means you only have 5 options to choose from. That's why we have 5/6. And then for the second dice that you throw, which is the blue one, you can't choose 1 either. So what's the probability of getting a number that is not 1? It's going to be 5/6 again. So 5/6 times 5/6, which gives us 25/36. So that's how we want to do that. Okay. All right. Then there's that. Okay. So that brings us to the end of this session for math. The only thing left that we need to do is probability trees. So we're gonna do that tomorrow. What I can do before just ending it, what I could do is let's do these practice ones. So we just can do it in passing. So this came from one of your past papers, 2015 past paper, and excuse me, it says the following. It says there are 13 competitors in a talent show. To determine the order of performances numbers from 1 to 13 are placed in a bag, and each competitor in turn randomly selects a number. Write down the probability that the first competitor to pick a number selects an odd number. So Caitlin, can you answer A for me, please? We get an odd number. What's the probability of getting an odd number?
Seven over 13.
Very good. 7/13. Sierra, what's the probability of getting a factor of 9? Okay, by the way, before I even say that, the reason why it's 7/13 is because there are 7 odd numbers. 1, 2, 3, 4, 5, 6, and 7. So there are 7 odd numbers, and it's out of 13. Okay, so just bear that in mind. That's why it's 7/13. Okay, go ahead, Sierra. A factor.
Okay, it's 3/13.
Okay, so it's 3/13. What are factors of 9?
1, 3, and 9.
Very good. So 1 can go into 9, 3 can go into 9, and 9 can go into 9. So there are three factors of 9 out of 13. That's why it's 3/13. Okay.
Write this.
Take a screenshot of it because we're gonna move from it quickly.
Can I do other one please?
Okay, sure, no problem.
I could do D.
No problem.
4 over
So the third
4,
one says you want a multiple of 3. So what's your answer for that one?
4/13.
4/13. Okay. Let's see. The multiples of 3 are going to be let me keep it red. It's going to be 3, 6, 9, 12. Very good. 4/13. Very good. Good. All right. So let's move on. So let me erase this. Clear our drawing. So remember the first one was The first one was 7/13. A factor of 9, that was 3/13. A multiple of 3, that was 4/13. Okay, prime number. Jasmine.
Okay. You want the list or just say?
Give me the list first.
Okay, it's 2,
Mm-hmm.
3,
Mm-hmm.
5,
Mm-hmm.
7,
Yes.
11, and 13.
11 and 13. Very good. So what is the probability of getting a prime number?
2/13.
2. Why you say 2/13? How much prime numbers do you have?
6,
Good. And how much you have altogether?
13. 6/13.
Very good. 6/13. All right. Sierra, square number.
Okay. It's 4,
Give me one moment,
6.
please. Give me one moment. Oh. Come in. All right. Sorry about that. Okay, so all right. Once again, um, all right. So square numbers. Deja, not Deja. Sierra. What square
Okay.
numbers? Go ahead.
4,
4.
6.
Not 6. Can't be 6. All right. Let's make our list of square numbers. So remember, 1 times 1 is 1. So 1 is a square number. 2 times 2 is 4. So 4 is a square number. 3 times 3 is 9. So 9 is a square number. 4 times 4 is 16. So 16 is a square number. So What are the square numbers that are part of this list?
Okay. 1, 4, and 9.
Very good. 1, 4, and 9. So it is 1, 4,
3
and 9.
over 13.
3 over 13. Very good. All right. All right. So this is how they assess you in your exams. It's not sometimes it's not as hard as the ones I give you, so at least that's refreshing. Okay, so this is a probability question, case in point. Let's do another one. Seeing that we have the time. So another one is let's not do that one. Let's do this one. Okay, so this is basically the same question. This one is from 2009. So they basically ask the same question because it's 13 numbers and we have defined the odd number, factors of 9, square numbers, and prime number, and multiple of 3. So basically it's the same question. All right, let's look at this one.
I have a question.
Go ahead.
Is it like this on the BGCSE or because I have never seen this? I only Scatry.
You have never seen what?
Like how the last time I saw a class laid out like that was BJC. Like when I got on the BGCSE, I thought that was gonna be there, but all I saw was that tree.
I say the tree. Okay, so this is paper 1 questions. Okay,
Wow.
yeah. So if you look at what question we get that from? That was what, 2015? You saw that? 2014. So if you look at the 2014 BGCSE, this is what, let's look at it. It's 2014, right?
Oh, that's why. I only worked from 2017 up.
Oh, okay. Okay, or the one we saw earlier. What I was from? That was from 2015, the year I took my exams. So 2015. That, yeah, that's exactly where we got it from. This is paper 1 though, so you expect paper 1 questions to be, sort of manageable. All right, so this one is from 1999. Anyone was alive here? 1999. Anyone? No one.
I think I was a figment of my mom's imagination.
1999.
I didn't exist yet.
Oh, okay. Yeah, 1999. Pretty long time ago. So Aaron buys a box of 20 Miss chocolates. He does not like 5 of them. He selects one chocolate at random. Find the probability that he will select a chocolate that he does not like. Okay. So, Sienna, what's the probability that he's gonna get a chocolate that he does not like?
$20.
Very good. 5 over 20. So the probability of him selecting a chocolate that he does not like is gonna be 5 over 20. So it can be simplified, Sienna.
5.
Yeah, we could use 5. So 5 divided by 5 and 20 divided by 5.
1 over
1 over what?
4.
1 over 4. Very good. 1 over 4. Okay. Okay, so that definitely brings us to the end of our maths class for today. Tomorrow we're gonna tomorrow's when we're gonna go over probability tree. Finally, we've covered all the ground that we need to be able to tackle that, and we probably just could stay on the probability tree probably till tomorrow and Thursday, but I don't know if I want to prolong it. But definitely we gotta attack that tomorrow, the probability tree, and see how that looks and works, and practice some problems with that. All right. Okay, so let's turn our attention to English studies. So the first thing I want to do for English is I want to try something a bit new for English, that at least for the beginning part. I'm gonna ask you. Oh, sorry. I'm gonna give you a word, and then I want you to give me the definition of the word in your own words. All right. So don't use Google. In your own words, tell me what it is. All right. If you do not know what it is, just say pass it on. All right. But don't use Google or any other resource. Just try to answer it genuinely based on what you know. All right. All right. So we're gonna want to go first. Who wants to go first? Anyone wants to go first?
Hey,
Okay. All right. So the word for you is procrastinate. What do we mean by procrastinate?
you trying to what?
Are you trying too hard?
Are you
No.
doing too much?
I think
No.
I know.
No, definitely not. Go ahead, Jasmine.
Slunking.
Say it again.
Like you slunking.
Yeah, exactly. You slunk in. Say it in a better way instead of using slunk it.
Um. Uh, I don't know.
Okay.
You're taking a very long time to do it.
Yeah, you're
Do
taking a exactly. So, you were given an assignment to do, and let's say you were given it a week in advance, and instead of starting the assignment, instead of starting to do the assignment the day it was given,
That is nice.
yeah, you procrastinated and you started next week, but the day when it is due, right? Now, people who procrastinate, we call them what?
Lazy?
Lazy. We call them
Procrastinators.
procrastinators. Yeah, procrastinators, right? Hopefully, there's no procrastinators inside the room. I hope. There are none in here, right? Right? Okay. Um. Okay. So, who's gonna go next? Anyone want to volunteer next? All right. So let me volunteer people then. Um, Jasmine. What do we mean by diligent? Diligent. If someone is diligent, what is that?
It's like doing homework every day.
They doing homework every day. Okay. It's close. It's very close. Anyone want to add on to that? Diligent.
Like doing what you have to do.
Doing what you have to do. Very good. So someone who is diligent is the opposite of someone who is a procrastinator.
Hardworking.
Hardworking. That's the word. Hardworking. They're hardworking. are not lazy. They are industrious. They make the best use of their time. They're like the ant, you know. Ants are diligent. They they they're not lazy. Okay, the next word is for Sierra. Sierra, you ready for this word?
Just knew it. Yes, sir.
They just knew it. Ah,
Okay, let me see my brain percolating today.
okay. All right, submissive. What do you mean by submissive?
Oh, no. I heard that somebody say you're being insubmissive, complaining.
Okay. Um, if you're not submissive, then you are okay. Let me give you a hint. If you're not submissive, then you are proud, you are boastful, you are um disobedient, right? You are rude if you're not submissive. So, what do you think submissive means?
Hardworking.
Hardworking? No, not definitely not
Can I
hardworking.
try? Oh,
Go ahead, try Albany.
humble, wise, good soul.
Well, that sounds like Google.
Like that's his character.
I
That
no, I
sound
don't know. Them.
that sound like Google,
You say too
man.
much words.
She say too much word. If you'd give me one word, then I would have believed you. But
You said
you
you are
keep,
proud, so the first thing I come to mind was wise.
you sure? That
I
sound
promise. I swear.
that sound like Google answers, but all right. But seriously, submissive means humble. Was not really humble, but obedient. That's probably the best word. Like, if you're submissive, you're obedient. You basically whatever someone tells you, you listen, right? So you're submissive, right? You're not the one who fight back, right? So that's what submissive means. All right, Kiara Linton, you ready for your word?
Yes, sir.
Okay. All right. Okay. So your word is exemplary. Exemplary.
Pass it on.
Pass it on. Damn what that means.
I don't know.
All right. Okay, pass it on. She said she wanna pass it on. Exemplary. Anyone else wanna help her?
Exemplary.
Yeah, exemplary, yeah.
If I get it wrong, but like when you can make an example or something like that.
Exemplary. So uh his service his service to the company is exactly what every boss would desire. It was exemplary.
Perfect.
Perfect. Okay. What else? Besides perfect. For exemplary.
It was outstanding.
Outstanding. Yeah, outstanding is a good one. It was excellent. It was, something that like you're a good, yeah, you're like a role model. All right. So you are, if we look at you, we can see exactly what to do. All right. Exemplary. It is superb. It is wonderful. Um, okay, Jonathan, are you ready for your word?
Yes, sir.
Okay. All right. So your word, Mr. Jonathan, is flawless. Flawless.
Me?
Flawless. Flawless.
Um, you you clean?
Say clean. Okay, clean is good.
Clean.
Uh,
Just nice.
yeah, I could accept that. So if something is flawless, it's clean. Or if you have a flawless character, which means that you don't do nothing wrong. If you have flawless grades, which means that your grades are perfect, it's, you know, it is, you know,
I didn't hear that word. Yeah.
yeah, it is excellent, flawless. Okay. Okay, who hasn't gone yet? Altonique, you haven't gone yet. Altonique, you ready for your word? I don't have Altonique. All right, so I guess we get to Deja. Um,
Okay.
go ahead.
Pardon?
Yes, your word. You ready for your word?
Yes, sir.
Okay. Um, your word is precocious. Precocious. What does that mean?
Oh boy. Um, precocious. Does it mean inquisitive, maybe?
Mm, close. Remember we saw this before.
I know. That's why my mind just suddenly went blank. Precocious. When they usually say precocious, they usually talk about children. So that's why I said inquisitive or
Okay.
innocent. I don't know.
Close. Very close. 6-9. Is this a dumb student or is this a student who is more, say, um, a level ahead of the rest?
You mean intellectual?
Okay. Yeah. Someone who is um more
Ordinary.
advanced than the rest of their peers, right?
Intelligent.
Yeah. All right. Precocious. All right. So that's a good mind teaser, right? To get your brains working on this good Tuesday. So let's begin with officially with English. Okay, my mouse. Okay, so let me erase. Let me clear everything. Clear all drawings of that. All right. So today is Monday, Tuesday, Today is Tuesday, the 16th of August. Sorry, pressed the wrong button. (2022). This is week 7. We only have one more week of summer. Boy, it feels weird even saying that. Oh wow. We only have one more week, of summer, and well, then we begin fall classes. Fall classes begins on August 29th. So you only have 8 weeks. We only had 8 weeks of summer classes. So yeah. So today is what? The topic rather. So that's the subject. The subject, yes. The subject is English language. The topic is avoiding sentence problems. I think this is a good topic for us to do. Avoiding sentence problems. We spend a great deal of time talking about joining sentences and stuff like that. But we're going to talk about how we can avoid sentence problems, and instead of writing a fragment, really crack down and write an actual sentence that expresses a complete thought. So some groups, so let's begin. So we wanna entitle it correcting sentence fragments. All right. So some groups of words, even though they have a capital at the beginning and period at the end, don't let that fool you. They are not complete sentences, but rather they are fragments. So the key concept in all of this is a fragment or fragment is a group of words that does not express a complete thought. So a sentence, on the other hand, expresses a complete idea. A fragment does not. A fragment can be a group of words with no subject. So a fragment could have no subject. with no subject, a group of words that includes a possible subject but no verb. Or I could be a group of words with a possible subject and only part of a possible verb. Or I could even be a subordinate clause just standing by itself, standing alone. Okay. All right. So with that in mind, let's create a table that has fragments on the one hand and then sentences on the other. Okay. So this one we're gonna have our fragments on this side, and on this one we're gonna have our completed sentences on the other. All right. So a sentence could be in the early evening. Sorry, a fragment rather could be in the early evening. Okay, so Sierra, why isn't this a complete? Why isn't this a why isn't this a sentence? Why is it a fragment?
Because it don't have a complete thought.
Exactly.
It only saying in the evening what? So
Exactly.
it's incomplete.
It's incomplete. Excellent. Wow, you sound like a teacher just now. In the evening, what? I like that. Ah, okay, good. So, well, a complete sentence could be the flight arrived in the early evening. Okay, so it tells us exactly what happened. Okay, so we don't have no missing information. For this one, we have felt happy and relaxed. All right, so of course this one, it is a fragment. You could fix it by saying, how could we fix this sentence, Deja? Sorry, this fragment.
Just put I in front.
Yeah, just put I felt happy and relaxed. We felt happy and relaxed, right? So I felt happy and relaxed. Okay. So it answers the question of who. And who felt happy and relaxed, right? Our next fragment could be the sign in the corridor. The sign in the corridor. You know, to make this a complete sentence, we can say the sign in the corridor is surprising. Okay. Um, how about this? The train coming around the bend. Um, is this a fragment, Deja? The train coming around the bend?
I think so. I think it's missing. Oh no, it has a verb, but like it's missing a helping verb.
So what is it missing?
A helping verb, like
So
is or was.
was, yes, right, exactly. The train was coming around the bend. Very good. So when she smiled. So when she smiled, oh, sorry, not when she smiled, when she first smiled. Um, let's put it like that. When she first smiled. Um, okay, how can we fix it? It's a fragment. We still need some more information. We can say when she first smiled, the whole world seemed to light up. Okay, it's a complete sentence. All right, and that's that. That's us comparing fragments with complete sentences. All right, so fragments doesn't give us the complete thought, only complete sentences. And so you want to make sure that when you write your sentences, um, you make sure it's not a fragment. Make sure that it expresses a complete idea. Make sure that it expresses a complete thought, so you don't leave the reader hanging. Like, what did what? Who did what? Where were they? Make sure to answer those questions with your sentences. Okay? We're gonna have an early night tonight. I'm gonna call it a night. Once you finish, write this down. Send me the math notes and the English notes, and then you can leave. So make sure Kiara and Jonathan, make sure to take a picture of your notes that you wrote and send it to my WhatsApp number. I have my WhatsApp number in the chat. That's 4268891. All right. So make sure to send me a picture of your notes as well.
Yes, sir.
All right. Okay. So have a wonderful night, and I'll see you on tomorrow at 6 o'clock. My class is at 6 tomorrow. All right.